So in this video I want to go over a basic vectors question, but at the same time I want to get through all the different bits of terminology and explain all sorts of things so that by the end of it you will know 90% of what you need to know for vectors questions. So let's get on with it. So this question is saying to begin with in part A, how do you get from B to A? And all these questions, the way they work is you have to put the answers in terms of vectors. So it's pretty easy. So what are the vectors? These are the vectors, these things in bold letters, and they just tell you how to get from one place to the other. So if I want to get from here to there, I just say A, but if I want to go back from A to O, then I'd say minus A, and stuff like that. You can see the arrows make a difference. So over here, from there to there, from C to O is C, and from O to C is minus C, and stuff like that. So I want to get from B to A. This arrow, by the way, just means you're to use vectors to get from the first letter to the second letter. They always just use two letters, and by the way, the arrow always has to go from left to right. You can't do it the other way and swap the letters around. It won't be the same thing. You just don't do that. So B to A means get from there to there. Now the way vectors work, they're like train tracks. A train can't just go wherever it feels like. It has to go over train tracks. So say I want to go from station B to station A, I just can't go across. I have to go like this. So I have to do a minus B, because you can see the arrow is going the other way. So it goes minus B plus A. And that's the answer, minus B plus A. And then you go, oh, hang on a minute, what's that squiggly stuff going on? Well, when you see in an exam a vector, it'll be written in bold because that's printed. Okay, and when something's printed, the standard thing to do is write a vector in bold, but you can't really be expected to write something in bold using your hand. That's not very practical. It just looks very messy. Don't know if you've tried it, but I have, and it's very messy. So what you're expected to do instead is put a squiggly line underneath it. So that means that's a vector. It means minus B of some vector and plus A of this other vector called A, basically. So basically it's saying from B to A, to get that answer, the answer is minus B plus A. Let's do something a bit more complicated now. We're going to get from A to C. Now the answer is actually pretty easy, it's just that, and this thing is just showing further working out to demonstrate kind of standard and good ways to show working out. And then this thing, don't worry about it in a minute, it basically gives the same answer. So this is some extra stuff I'll talk about in a few seconds. So anyway, I want to get from A to C, and I have to follow the vectors round. So the easy way is to say, well, it's minus A minus C. Yeah, it's the opposite of this arrow and the opposite of that arrow, so they're both negative, and obviously I have to say A and C because they're going over the vectors A and C, except for they're going over them backwards. So from A to C, it's minus A minus C. And that's the answer, done. Okay, now what's this stuff? It's just kind of showing a bit of method, explaining what's going on. How did I get from A to C? What route did I take? Oh, I took this route. I took the A to O route, and then I followed it with a O to C route, so I went from A to O, and then I went O to C, and I added them together, I put them together, and I got this answer. But alternatively, I could have gone some other route like this route, A to B and then B to C. Why not? Because what you can do is work out what A to B is. Oh, it's minus A plus B, and then you could work out B to C, which is the other bit, so I'm going like this. B to C, what is that? Oh, that's minus B plus, minus B and minus C. So A to B we said was minus A plus B, minus A plus B, and we said b to c there is minus b minus c, like it says over there. I put it in a bracket, I didn't have to, but it kind of shows that this is this thing and this is this thing here. It's mathematicians like to lay stuff out so it's easy to follow. They call it beautiful. They consider that beautiful maths when it's easy to follow. So if you want to do that, if you want to make examiners happy, do that kind of stuff. Anyway, so let's add this all together. We can add it just like normal letters. I know they're vectors, but you just treat them like normal letters. So minus a plus b plus minus b. So that's basically saying b minus b, which is nothing, which basically leaves you with minus a minus c, which is the same answer. So what I'm trying to get at by doing this long way round is that it doesn't matter which route you take, you're going to get the same answer. That's the thing I really wanted to point out. So I've kind of explained a lot of what we call notation, how to write stuff in vectors. There's one more tiny thing I want to explain, and is how can you say, for example, that from here to there is the same as that plus that, because it doesn't look right. Now what you'd have to do to understand that or appreciate that is go back to where vectors came from, which is the numbers that make up vectors, right? And remember, if I briefly explained this before, that if you add two vectors, the result is the shortcut of those vectors. So for example, a vector might say, go right 2 and then this and down, I don't know, 5, and this one is saying go right 2 and up 5. So bits of the vectors cancel out and bits of the vectors add together and overall produce the same result. So I think if you're really confused about it or you really want to understand that, just check out my previous videos about vectors.